but I believe that the basics that you can find in that tutorial, but I will try to more focus on media streaming. Okay, so media streaming, how it may look like. From voice API, it is supported from dial, answer, and dedicated streaming strat endpoints. Here's an example of dial endpoint, I mean calls which making dials. And here you can see that there are only a few attributes that are needed. Streaming tracks, streaming URL, the most important streaming URL, that is the address of your WebSocket server that will connect to and send the audio and get the audio from. And the bidirectional mode, I'll talk a bit about that in a moment, but in general we've got two modes. Yeah, I will talk more in a second. Here is an example of the flow, how it may look like. From the voice API application when you make a dial command and making a call. So first of all, you are making, as I mentioned, dial command, our telnex telephony service internal, making a call to the desired caller. At that moment, the WebSocket is being established to your server, and once it is established, we are sending the first event, which is called connected. Then when the caller answers the call, except of course of other webhooks, we are sending streaming started webhook. I mean other webhook like call answered. And at that moment we are sending as well start event over WebSocket to your WebSocket server. The following, I mean once people start caller and callee, or maybe only caller, start speaking, then we are sending the media event that contains the audio stream. You may get as well DTMF events, what means that if someone presses some keys on the call, you will get DTMF event. On the other hand, in the other direction, you can send media event with your audio. You can send mark and clear events that can be used for if you want to know if something was already spoken, you can send the mark event after the media that's important for you. And once it is spoken on the call, we'll send you back the mark event. Yeah, it should be mentioned here as well, that it might be marked. Clear means that you don't want to this media that's already sent to be spoken on the call, what means that the queue is just being cleared. Yeah, and we are just waiting for following media events. Once the caller or the callee hang up the call, we are just sending stop event, and the connection to the WebSocket is being stopped. And of course, streaming stop webhook is being sent to your voice API. So this is the flow. Here you can see how to enable it from XML. We support two ways. One, it is just within start verb, you can add stream verb none after that, and define all the connection details similar to voice API. As well, you can use connect instead of start, and the difference between those two ways is that connect is blocking, what means that the next operation won't be run or executed until the stream is running. In case of start, the stream will be started, and the following of instructions will be executed immediately. Yes, and you can use as well dedicated XML REST endpoint for starting streams. So you are not only limited to the XML streams. Yes, and now let's talk about bidirectional streams. This is those two types that I mentioned before. Historically, we supported only one, MP3, but now we've got two, and that, I believe, makes this feature more capable and better for integration with all the AI solutions. So this first, very basic, is based on the files, MP3 files. That simplifies the solution on your side for your middle layer. However, it is designed for longer playbacks. If you try to use very short playbacks, the gap between them might be noticeable. So if you have the real-time streaming, the RTP option is for you. This is designed for low latency audio streaming. The call, it uses RTP streaming. That means that your middle layer will be more complex. Yeah, I mean, we'll see that in the moment on the demo section. It is not very complex, but yeah, definitely file-based is a bit easier. Yeah, so here, now I would like to talk with you about the encoding of the stream, because for many of our customers, I mean, it is not the easiest thing. So let's talk this technical aspect of media streaming. So I believe that's right place now to discuss that. So let's start with the outbound stream. Outbound from Telnet's perspective, what means the audio that we are sending from us to you. The encoding can be set. I mean, we are sending using the same codec as is negotiated on the call. So if the PCMU was negotiated on the call, you will get the streaming using the same coding. So we are not doing any transcoding in that direction. And your preferable codecs can be set on voice API application settings for inbound calls. And for outbound calls, you can use preferred codecs field in the dial transfer or transfer commands or in the XML to set the codecs that you want to have. Yeah, what is important that, of course, we can negotiate only those. I mean, if you are making external calls to PSTN vendors, we can use only those codecs that they support. Of course, for telephony, default codecs are PCMU in the US and PCMA in EU. But if your scenario is to make Telnix in-house, I would say, calls, then you can use as well HD codecs. You can use higher frequency and so on. Yeah, and for streaming encoding, I mean for inbound stream, so the stream from you to us, you can set it as part of every command. For every command, we've got a parameter which is called streaming bidirectional codec. And using that field, you can set the codec that you are going to use for sending us the RTP stream. You can use all the streams that are HD streams and any streams that are supported. Please be aware that it will, if it's not aligned with the codec on the stream, it will be transcoded, what means that the quality might be reduced. Transcoding, and one more point, transcoding is not supported for AMRR WB codec. In that case, if there is misalignment between the stream and the codec on the call, you will get an error because we cannot transcode that codec.